Hello student, today's question is evaluate integration x square minus y square plus 2i xy dz over c, where c is the circle modulus of z is equals to 2, right? So first of all here c is the circle modulus of z is equals to 2 is given, right? Now, we have to evaluate this integral. Before evaluating this integral, we must know that one result, or we can say theorem. So, theorem, if C is simple closed curve lies in domain D and f of z is analytic inside C and on C with f dash of z is continuous, then integration f of z dz over a closed curve C is equals to 0. With the help of this theorem, we can evaluate this integration, right? So, given, what is given here? C x square minus y square plus 2i xy dz, which is equals to capital F of z dz. So what is capital F of z here? X square minus y square plus 2xy iota. Okay. Let us try to show that this function is analytic inside this C. Then we can conclude that integration is 0. Right. So here we can write it as it is u plus iv. So this u is equals to x square minus y square and v is equals to 2xy, right? Now, how to check that analytic f is analytic function? First of all, we have to satisfy the Cauchy criteria, and after satisfying the Cauchy criteria, we have to just conclude that ux, uy, vx, vy are the continuous function. Then function becomes an analytic function. Correct? Now here ux means partial derivative of u with respect to x is 2x. Uy partial derivative of u with respect to y, which is minus 2y. Vx is 2y and vy is equals to 2x. Now clearly here, clearly ux is equals to vy and uy is equals to minus vx. Correct. Now, first condition is satisfied, that is Cauchy criteria. This is the Cauchy criteria, right? Ux is equals to vy and uy is equals to minus vx. Now as ux, uy, vx, vy are polynomials in x and y. So as we know that the polynomials are the continuous functions, so this implies ux, uy, vx, vy are continuous functions, are continuous functions, right? So this implies from CR equation and this condition we can conclude that f of z is equals to u plus iv is analytic function. And we also know that if f of z is analytic, but obviously f dash of z is also continuous, as f dash of z is equals to ux plus I Vx. Correct. Now, as ux and Vx is continuous function, that means f dash z also continuous, as ux and Vx is continuous. Correct. So, by Cauchy theorem, by Cauchy theorem, okay, what Cauchy theorem says that if C is a simple closed curve, lies in the domain D, and f of z is analytic inside the C and on C, with the f dash of z is continuous, then integration C f dash f of z dz is equals to 0. Now, from this, f of z is analytic function everywhere, right? Everywhere. So we can conclude that f of z is equals to u plus iv is analytic inside, analytic in C and on C, right? So as f of z is analytic everywhere, that means we can say that f of z analytic inside this C and on the boundary also, right? Inside this C and even boundary also, right? This boundary. Hmm. So by Cauchy theorem, integration C f of z dz is equals to 0. So this implies integration C. What is capital F of z? It is x square minus y square plus 2xy iota dz is equals to 0. So this is our final answer. Right. I hope you understood that. Thank you.